An athlete in a hammer throw event is swinging the ball of mass 7 kilograms in a horizontal circular path. The ball is moving at 20 meters per second in a circle of radius 1.6 meters. Calculate the magnitude and the acceleration of the ball. Okay, one thing that I like to do in situations like this is write down what we know and write down what we want to know. And this is useful when we do our SUVAT equations later. So, what information do we have here? We have the mass of the ball. We know our mass is 7.0. We know our speed is 20. We know our radius is 1.6. We know all those things. We want to know our acceleration. So what we can do, if we have all of these variables that we're using, if we look back on our previous slide, we can see which formula we need to use. We want to find A, we have V and R, so therefore we can use A equals V squared on R. So our V is going to be 20 squared on 1.6. What is that going to be? Yeah, 400 on 1.6?
250.
250, thank you. 250, what are our units? Meters per second squared. It's an acceleration. All right, so we've got the magnitude. Oh, it doesn't tell us to put the direction in, but which direction is it acting? Center of the circle. Okay, our acceleration is always acting towards the center of the circle. Okay, calculate the magnitude of the tension force acting in the wire. So, we have, I'll do a bird's eye view here. We have a ball, a hammer acting in a circular motion. We know that F net is acting inwards. And remember, the F net has to be caused by something. Our centripetal force has to be caused by something. In this case, it is going to be the tension force of the wire. So our centripetal force, our net force, and the tension force in the wire are all the same thing. Okay? So we can do it the long way. We can look up how to work out the force on something in circular motion. And we can do mv squared on r. We can work it out like that. Or what we can do is just multiply our acceleration by the mass. Okay, it's exactly the same thing. So our mass is 7 times 250, which will be, what's that, 1750 newtons. All right, so this is an important concept to get your head around. In circular motion, the net force is the centripetal force. They're the same thing. And it always acts towards the center of the circle. The acceleration always acts towards the center of the circle. And you can just use the formulas from the previous slide to work those out. All right, any questions? Okay, try the next one.